All right, so we're going to be looking at some angle postulates and properties. And the first thing we want to do is define what an angle is. So this is going to be added to your theorem and your postulates notes. And over the top there, we're going to scratch out postulate and theorem, put definition. And the first thing we're looking at is an angle, okay? So we want to define what an angle is. And an angle is a figure formed by two non-collinear, in other words, not on the same line, okay, non-collinear, rays that have the same endpoint. Okay, so again, if you need to hit pause and copy this down and then we'll continue on, but it says it's a figure formed by two non-collinear rays, so rays that do not lie in the same line, but they do share an endpoint. Well, what would that look like? Well, it could look like this guy, okay? So notice I have two rays here that share this common endpoint, okay? Now we could call this common endpoint F, and we could say that there are two other points on the ray, okay, E and maybe G. Okay, and so this would represent a figure of an angle, okay? Now let's kind of break down the different parts. So we know that F, all right, I should say, we are going to define that F is the vertex, okay? So F is the vertex of our angle, and then we can also define the two rays as sides, okay? So ray FE, remember we always start with the endpoint, ray FE here, this guy right here, okay, is a side, and ray FG, this guy right here, that guy is also a side, okay? So F is the vertex, ray FE is a side, and ray FG is a side, okay? Now, that is what it looks like. That's what the different parts are of an angle. Now let's talk about how we can name an angle and the different types of notation that we can use, okay? An angle, let's write this over here in the example explanation. An angle is named using 3 points that includes the vertex and two other points. Okay, so we need the vertex and two other points, specifically those two other points, one from each side. Okay, so we need the vertex and then two other points, okay? Well, just like in our example here, we have F as the vertex, and then we have E on one side and G on the other side. So this would be enough information to now name this angle. And there are different ways that we could name this, but the key, the most important thing when we use 3 points is the vertex is always in the middle, and we use this symbol to denote an angle, okay? So we could call our example EFG. EFG, okay, where the vertex in the middle. So what we're saying is I'm naming this angle E for the first point, G for my vertex, or excuse me, F for my vertex, and then G for my third point here, okay, so EFG. Now we could also name it the other way. We could go the other way and name it GF, F still in the middle, E, okay. Another way we can name this is GFE. So these are probably the two most common ways that you'll see an angle named. Another way that you can name an angle is if we just put a value, let's say that we had some number on the inside of the angle, like 2. Sometimes you might see that. We could call this angle, angle 2. Okay, it's not quite as common, but that is another way to name it. And every once in a while, but there's a stipulation to this, you might just name the angle based on its vertex. Okay, our vertex is F, so we could call this angle F. Okay, but the only way that works is if there are no other rays attached to F. okay? If there are any other angles attached to F, that is not specific enough, okay? So it only works if there are no other rays attached, and we're just talking about this angle here, okay? So that would be an angle. Now, before I move on to other definitions, I want to talk about the first postulate we're going to look at, which is the angle measure postulate. Okay? And that says for every angle, there is a unique positive number between 0 and 180, called the degree measure of the angle. Okay, so the angle measure postulate says for every angle there's a unique positive number, okay, a positive value, representing the basic units that angles are measured in, okay, from 0 to 180, and the basic units in which we measure an angle is called a degree, okay? Just like on a ruler, you might measure things in inches, we measure angles in degrees, and we're talking about the measure between 0 and 180, okay? Now, in a circle, there's things like 360 degrees, but for our purposes, we're focusing on this, okay? Now, what that might look like in terms of an angle is maybe we have some angle like A, B, and C, and we would say that the measure of this angle might be like 30 degrees, okay? That would be the measure of that angle. And the way we would notate that in terms of notation is instead of just putting our angle A, B, C, so remember we name our angle with 2 points on the one on each side and then B, the middle, the vertex, the way we notate a measure is putting M in front of that. So this would be the measure of angle ABC is equal to 30 degrees. So if we wanted to name the measure of the angle, we just got to put this little M in front, okay? So what that does is that helps us set up the definitions now for a few other types of angles here, okay? The first one we're looking at is an acute angle, okay? And it's an angle with a degree of measure between 0 degrees and 90 degrees, okay? And so this little circle above represents degrees, just like when you think of like Fahrenheit, but we're talking about degrees in terms of an angle, okay? So an acute angle is an angle with a degree and measure between 0 and 90 degrees, okay? Well, what does that look like? Well, those guys typically kind of look a little skinnier, kind of like in that example we saw with the 30-degree angle, okay? So it's a little bit thinner or skinnier in terms of the width, or excuse me, the measure of the angle. Try to say that a little bit better, okay? So another type of angle we could run into is an obtuse angle and a right angle. Let's do right angle first, okay? So we have right angle, and that's an angle with a degree of measure equal to 90 degrees. Whoops, there we go. Okay, so what separates this from an acute angle? A right angle is measured exactly at 90 degrees. So remember when we were talking about perpendicular lines, okay? Perpendicular lines meet at a right angle, 90 degrees. Well, a right angle in this case, we're kind of ignoring all of this, and we're just focused on the angle that is formed right here, okay? So a right angle looks like this guy, okay? And the way we notate a right angle is this little box, okay? This notates that we have 90 degrees, a right angle, okay? Now, the other type of angle that we could run into, let's go back to black, there we go, is an obtuse angle. Okay, an obtuse angle is an angle with a degree of measure greater than 90 degrees, so bigger than 90 degrees, and less than 180 degrees. Okay, so an obtuse angle is bigger than a right angle, but it's still less than 180 degrees. And there's a special case for 180 that we'll see later, but it might look something like this. So it looks a little bit like it's open wider. Let's try that again. There we go. Okay, so this angle looks like it's open wider. So the acute angle look kind of thinner. Right angle is straight, almost like when we're talking about the perpendicular lines, they meet at a 90-degree angle. And then obtuse looks like it's kind of wider. Okay, so then the next situation we run into is what happens when it's exactly 180 degrees. And that's that guy that we talked about earlier, opposite rays, or sometimes as we'll call it, a straight angle. Okay, but for right now, we're going to put opposite rays. Okay, and opposite rays are collinear rays, lie on the same line, rays that lie on the same line, that only, share an endpoint. Okay, so they only share an endpoint. You can think of it, they're facing opposite directions, and oftentimes we'll also call this a straight angle, a straight angle. Okay, why? Because it forms a straight line. Okay, so we could take an example like this. Let's say I have ray yx. Okay, this would be a ray, and then its opposite ray would be, it shares the common endpoint y, but it's facing the opposite direction, and let's say we have the point z. So what we have here is we have the ray yx right here, but then we also have a ray yz right here. So they're opposite rays that share this endpoint, okay? However, they form a straight line or a straight angle. So the measure of this angle is 180 degrees, okay? 180 degrees. So that would be the opposite rays, the straight angle. The degree, we should add this in there, the degree measure is 180. Okay, so then the next thing that we want to look at is interior of an angle. Interior of an angle. Okay, now this one is a little bit lengthy, so please feel free to hit pause. So it's a point is in the interior of an angle if the ray drawn through it from the vertex divides the angle into two smaller angles. Okay. Now you might say that's a lot of information to process at once. This is basically saying a point is in the interior, okay, the interior of an angle. For instance, if I had this angle here, we would say this point is on the inside of this angle because we can draw a ray through it from the vertex. And when I draw a ray from this vertex out to here, notice that creates two smaller angles from the original angle, okay? So we would say that point right there, going back here, that point would be on the interior of this angle, okay? Then the next thing we want to talk about is the exterior of an angle, okay? A point is in the exterior of an angle if the ray drawn through, tried that again, it from the vertex does not, okay, big not there, divide the angle into two smaller angles. Okay, so this is the exact opposite there. So what this is saying is the exterior, if we have a point that's on the exterior of this angle, I could draw a ray through it, but notice it doesn't divide the original angle into two smaller angles. It doesn't take this guy and divide it into two separate ones, okay? So we would say that would be on the exterior, okay? On the exterior of this angle, okay? Now, the last thing that we're going to talk about is the angle. See if I can get it. There it is. Okay. The angle addition postulate. Angle addition postulate. Okay, and what that says is for any angle, for instance, let's say I had the angle PQR. If there's some point A, so we have some point A is in the interior, so we just talked about what the interior is, interior of the angle, then the measure, remember if we put an M in front of the angle sign, it means the measure of, in terms of degrees, the measure of angle, skipped one, PQR, plus the measure of angle AQR. Oh, no. This should say A, my bad, guys. PQA plus the measure of AQR equals the measure of angle PQR. Okay, that's better, okay? So what this is saying is if I have an angle, let's say I had the angle P, Q, and R, okay? And there's some point in the interior here, some point A, then if I drew this vertex, or drew a ray from the vertex through A, it now divides it into two smaller angles, correct? Okay, so what it's saying is this angle PQA, so this angle right here, PQA, this angle's measure, plus the measure of AQR, the measure of this angle, has to equal the total angle's measure, PQR. So this angle plus this angle's measure has to equal the total measure of the whole angle PQR. Okay, so that's what that's saying there. So the measure of PQA plus the measure of AQR equals the measure of PQR. Okay?